Hello there, gentlemen. This is Rich Cunliffe, 65 Club member. My talk today is a layman's presentation on artificial intelligence, also referred to as AI. Artificial intelligence does not exist today in its ultimate actual intended form. After all, this presentation is also about what AI isn't. Full human-level artificial intelligence is unlikely to be achieved for many decades to come. Full AI is the ability for a computer program to observe, think, recall, analyze, learn, problem solve, self-correct, and make decisions unsupervised and autonomously based on what it has been taught and on what it has learned on its own, and to have reached a normal level of consciousness, and to do so at least as well as the average human brain. It has been said that one day AI will become the most significant technology in human history. We're certainly not there yet. Learn, problem solve, and make decisions that exist today. These limited forms of AI are usually mostly control dependent programmed supervised systems based on having been trained to do specific tasks. An AI machine that has been specifically programmed to defeat a world champion chess player is unlikely to be trained to tell you who Babe Ruth is. There was a recent 60 Minutes segment, September 6, 2020, in which we saw AI being used to read, in part, what you are thinking. All the efforts to eventually achieve full artificial intelligence is by way of trying to mimic the functioning of, on average, a 3.3-pound human brain that is the fattiest organ in the body. So, since fat is essential to a well-functioning brain, maybe calling someone a fathead could be considered a compliment. But don't make a habit of it. The brain consists of a mass of firm jelly containing 75% water, with about 85 billion neurons, or upwards of that, and about 10 times as many glial cells. Together, this brain functions on only 12 to 25 watts of electricity, enough to power a small, dim light bulb. If you were ever called a dimwit, think positive. Overall, your brain is still smarter than the most advanced AI at the present time. In contrast to the kilowattage of today's immensely powerful state-of-the-art computers, our seemingly undersupplied brain can be thousands of times more energy efficient than AI computers. To create AI to mimic these trillion-plus brain cells is an extraordinary goal, especially when we don't yet fully understand their functioning. What is intelligence? The most basic and perhaps the best definition is intelligence is the ability to accomplish complex tasks. The definition for AI is we have, for today's purposes, non-biological intelligence. However, many scientists foresee that AI will eventually be equal to or exceed general human intelligence. Full AI is intelligence that involves computers or machines to accomplish complex tasks or tasks too repetitive, time-consuming, difficult, dangerous for humans to do. Think of the Japanese Fukushima Daiichi disaster in 2011, where robotics were used to enter uh, uh, power stations that had blown up or melted down. 5 basic differences here between the brain and AI computers. First, unlike our brain that electrochemically transmits information, AI computers send information faster by electricity by using binary on-off switches. The second, that the brain, however, is both hardware and software. It uses the same interconnected areas linked by billions of neurons and trillions of glial cells and synapses. Thirdly, and because those cells use the same interconnected channels, they can observe, store, interpret, analyze, and redistribute information at the same time. The brain is more efficient in that there isn't that separation between software and hardware. Another distinction is that humans cannot work without emotions, for better or worse, whereas AI computers act mathematically and logically. And fifth, the human brain at this time cannot be updated, although some humans choose to self medicate in order to enhance their brain's functioning. Any self medicators here? Vitamin pills, maybe. A computer, on the other hand, can be updated with the latest evolving technology. And the winner is, okay, if we take a look at how computing wins out over the human brain, in terms of input and output, information processing, and memory. At this time, the computer is superior. If you take a look down at the brain still wins in creativity, emotion, empathy, planning, and executive function and consciousness, the brain still wins out, at least at the present time. AI hype or promise? Here are some quotes. This is the first one is by Sundar Pichai, Google's boss, and he says developments in AI will be more profound than fire or electricity. Uh, the next quote: AI will add $16 trillion to the global economy by 2030. And the next one is by Demis Hassabis, co-founder and brilliant CEO of DeepMind, which is creating some fascinating AI technology. And he says AI is going to be the most important technology ever. And the last is by Alan Turing, the intellectual father of AI. He would have made this before he died in 1954. This is only a foretaste of what is to come. And you are certainly right about that. As has been stated, the simplest definition for AI is non-biological intelligence. These three concentric circles shows the relationship between the three levels of AI. The first is the original term of AI that emerged, coined in 1956 by John McCarthy. The second wave of even more sophisticated technology known as machine learning. And thirdly, now deep learning that attempts to imitate the neural networks and functioning of the brain, all three together striving to reach full AI. But before we get to machine learning and deep learning, we should first look at algorithms. An algorithm is an indispensable driver of machine learning and deep learning in mathematics and computer science. An algorithm specifies a series of unambiguous finite steps that perform a particular task of computation instructions that allows a computer to complete a task. The image seen here is a typical computer coding for an algorithm. I don't know what this particular algorithm in this image is for, but this algorithm might have something to do with how to screw in a light bulb. I'm just guessing. I just read a humorous commentary by a South Asian journalist that some Indian parents in India are teaching their infants to code as soon as they have learned to walk. Now, there's a thought. An algorithm's instructions is essential to AI functioning. An algorithm is used as a specification of specifications for performing calculations, automated reasoning, data processing, and other tasks. Uh, Here we see a very simple version of that, the wait time at a restaurant. Shall I stay or shall I leave? The AI is any form of a broad field of emerging machine technology and learning that tries to simulate human reasoning in numerous ways using algorithms. In this slide, I'm referring to cutting edge AI. It reads, the key computer systems being AI is that they get better and more accurate as they collect and analyze more data without explicit intervention from humans. Machine learning involves systems that adapt and learn and are able to work with data that is not well structured, well defined, or even numeric. The more sophisticated an algorithm is, the greater its complexity. Some have said that the name machine learning sounds more technical and less frightening than AI. Now, here are three types of machine learning. Decisions made by various AI machine learning systems occur when these machines are able to learn from the vast quantities of data they are fed and understand the underlying patterns contained within them. Then, through pattern matching and further analysis, they come up with an outcome which can be, for example, a classification or a prediction. Machine learning uses thousands of millions of examples to train a software model. Uh, it can even take days, weeks, months of processing to train a state of the art machine learning system to digest the data that has been programmed to use before it can function in performing a specific task. Not only does it take much time and effort, but it can be quite expensive for a corporation in terms of the vast data collection, the incomes of highly skilled programmers, and the cost of electrical power. Electrical costs alone can cost millions of dollars in electrical consumption, making some large scale machine learning projects to be quite prohibitive for all but the larger internet and computer corporations, like the tech giants Google, Amazon, Apple, Microsoft, Facebook, and healthcare, insurance, and manufacturing sectors that can afford these high costs. The average time allocated for AI programming tasks as a percentage of the total programming. Time has to be allocated for such project tasks as cleansing, labeling, augmentation, aggregation, identification, model training, model turning, algorithm development, and operationalization. But once trained, a machine learning model can repay the effort over millions of automated decisions. Even more technologically advanced is what is called deep learning that uses these neural networks. It is a new area of machine learning research. Deep learning is based on highly complex neural network algorithms that you see here, inspired by the biological structure of the brain and its interconnections between neurons. It has been said that thanks to deep learning, AI enables many practical applications of machine learning and, by extension, the overall field of AI. Just briefly looking at this, the yellow indicates the output, the red the input, the blue dots memory, the pink kernels or clusters of uh, information, I suppose you could say, and the green is hidden. I guess that's where the mystery activity takes place. Deep learning versus machine learning. Machine learning algorithms um, are used to analyze data, learn from that data, and make informed decisions based on what it has learned. Deep learning structures algorithms in layers to create an artificial neural network that can learn and make intelligent decisions on its own. Looking at the machine learning column, machine learning can train on lesser data. Uh, well, let's look at the deep learning instead. That's a more advanced. Deep learning requires large data, provides high accuracy, takes longer to train, requires uh, uh, better processing units to train properly, and can be tuned to various different ways. Deep learning uses. Detecting developmental delays in children, for example, used in visual recognition, fraud detection, language translation, uh, adding sounds to old movies, and so on. This shows you the uh, various levels of artificial intelligence, starting back in the 1950s with artificial intelligence and advancing to machine learning, AI techniques that give computers the ability to learn without explicitly programmed to do so, and then deep learning, a subset of machine learning, which make the computation of multi-layer neural networks feasible, starting just 10 years ago. AI draws on the following sources for its development. Machine learning became a popular in 2010s, um, if not earlier, when new machine learning techniques led to rapid improvements in such tasks as recognizing pictures and manipulating language. Machine learning then spread to businesses, starting with the internet giants. There in the upper left corner, you have a graphic processing unit, which has really propelled artificial intelligence. The GPUs have now started to be replaced by something called TPUs, even more advanced tensor processing units, which can be 10 to 50 times more powerful than the GPUs. The market for these specialized AI integrated circuits and chips is already worth about 10 billion this year and likely to be 80 billion by the year 2025, according to Alfonso Marin, KPMG. Going to the right of the GPU image, we have big data. The world is awash with data, the lifeblood of AI. In 2018, the world has generated enough data to fill an estimated 7 trillion DVDs. What is big data? It involves the quality of the data, the variety of it, the speed and accuracy, and the immense volume of it. Future technologies include 5G, 6G computing, cloud computing, also the great engineering challenge of quantum solutions involving big high-speed computers to solve an optimization problem in which a computer is trying to make trade-offs between millions of variables to arrive at a solution that minimizes as many variables as possible. Now that sounds rather counterintuitive. And another future technology is neuromorphic chips that mimic more closely the electrical behavior of the brain's neurons. Going to the right of, in the upper right corner, we have the programming of a computer. We talked about here the algorithms. Going to the lower left corner, the deep learning that I had mentioned earlier. And The fifth area of advances in AI is moving from natural intelligence, developing theories of how the brain works to make a stronger AI. This cover is from National Geographic, September 2020. The front cover, as you see, recognizing the 100th anniversary of the term robot that originated in Czechoslovakia in 1920. 100th anniversary. There are now 2.4 million robots at work in factories around the world. Most of these are not much more than giant arms bolted to the floor that weld and paint things, according to The Economist from August 29th, 2020. Robots' capabilities are increasing. An experimental humanoid robot built at Boston Dynamics can now walk, run, jump, and even perform backflips. Honda, which has been a sponsor of this, has withdrawn its money because they say a robot doing those gymnastics is not much use in making an automobile. I want to share with you a quote from National Geographic from this issue on page 52, and it reads, "Already in 2020, robots take inventory and clean floors at Walmart. They fetch goods and fetch things for mailing in warehouses. They cut lettuce and pick apples and even raspberries. They help autistic children socialize and stroke victims regain the use of their limbs. They patrol borders and attack targets deemed hostile. Robots arrange floors, perform religious ceremonies, do stand-up comedy, and serve as sexual partners." Yes, that's on page 52, the National Geographic, and there is no centerfold that goes with that. Artificial intelligence, a way of making a computer, robot, or software think and act like a human. What is the difference then between robotics and automation? Robotics is the process of designing, creating, and using actual robots to perform certain tasks. This is from Google, definition, November 29, 2019. And automation, on the other hand, is slightly different. Automation is the process of using physical machines, computer software, and other technologies to perform tasks usually done by humans. Think of a two-circle Venn diagram with a very large overlap. In recent years, you may have invited Alexa or Cortina into your home as your AI personal assistant. How many of you make use of Alexa or Cortina? As you see in the lower right corner. And if you go to the lower left corner, much attention in the past 3 years has been devoted to creating self-driving cars involving AI. Safety problems have stymied progress for now. Elon Musk has shown particular interest in these vehicles. His Tesla cars, though not yet self-driving, come close with powerful autonomous driving systems on board with at least 21 sensors, including cameras, ultrasonic sensors, and radar. You can go to the Tesla dealership near where Grove Street meets Route 70 to see for yourself some of the amazing technology in these cars. Now, take a look at the far left of the screen here where it says play against computer. These days, specifically programmed AI are likely to beat you at your favorite board game or computer games. They ought to. Many have, in part, been created by AI technology. Talk to reigning world chess champion Garry Kasparov, who in 1997 got beaten by IBM's Deep Blue computer. Talk to reigning Jeopardy quiz show champions Ken Jennings and Brad Rutter, who in 2011 got beaten by IBM's Watson computer. Talk to Fan Hui, the world's best player at the Japanese board game Go, considered the world's most complicated board game, who was defeated in 2016 by IBM's Deep Blue AlphaGo computer program. The Internet of Things. This is the familiar common form of artificial intelligence. Those everyday uses of AI become increasingly indispensable part of our lives are now known as Internet of Things or IoT. The term refers to embedded computerization where internet connectivity and computing capability extends to objects, sensors, and everyday items that are not normally considered computers. Those are general, all-encompassing computerizations for numerous devices. Here are some IoT examples. Countless tiny chips are embedded in beehives. There are Wi-Fi connected, camera-equipped refrigerators that let you check on contents from anywhere in the world. Don't quite see the use of that, but anyway, there are diaper sensors that monitor sleep patterns and indicate diaper change. There are smart toothbrushes, smart light bulbs, smart detectors, smart ovens. There are smart doorbells, smart dishwashers, smart washing machines, and traffic lights. There are mattresses that track heartbeats and sleep patterns and body movements. There are medical device implants that can contact your doctor or medical facility. Factory robots that allow algorithms to predict when they will break down. Vast amounts of data gathered from these small embedded chips are fed to and analyzed by much more powerful AI machines and data centers that excel at extracting useful patterns about us the consumers. In 2020, there will be, by one estimate, 35 billion devices globally connected to the internet. The internet connected digital intelligence of the IoT makes the world smarter and more responsive. Toward the end of this year, an estimated 127 more devices will be connected to the internet every second. And there are, as you may already have and be aware of, internet connected devices in your home for medical purposes, such as wearable and home health and monitoring devices, etc. For transportation, as with Tesla cars, Bluetooth, global positioning systems. And by the way, on transportation, commercial airline pilots fly their latest Boeing passenger aircraft for only about 14 minutes on average, 7 at takeoff and 7 at landing, unless there is some emergency that kicks in. And then, of course, there's messaging with email, Zoom, Twitter, blogs, Siri, Cortana, Alexa, post office tracking, and so on. On the first day of 2020, I'll read this, about predictive analytics. On the first day of 2020, an AI warning system run by Toronto startup Blue Dot flagged a news report from China about a mystery strain in the city of Wuhan. The system, which sifts through 100,000 articles and online posts daily in 65 languages, alerted Blue Dot's human employees, who then immediately saw parallels to the deadly SARS outbreak in 2003. This was several days before the Centers for Disease Control in America and the International World Health Organization issued their public warnings. This is about AI supercomputers working on a coronavirus vaccine. Tremendous progress has been made here. Supercomputers for a detailed analysis of 8 million pairs and 15 billion triple drug combinations stemming from 4,000 approved drugs already on the market. And by the way, COVID-19 is 1/10,000th of a millimeter wide. Beware. Then there are drones for delivering supplies and for quarantine compliance. There are AI is used to reduce human-to-human contact in hospitals. The picture on the right are ultraviolet lights for killing bacteria as these machines progress into uh, rooms and down hallways with their ultraviolet light. This has been an enormous breakthrough this year. AI protein folding algorithms solve COVID-19 structures faster than ever. Deep learning makes its mark on protein structure analytics. Incredible breakthrough. And facial recognition and thermal imaging technology has spread well beyond COVID-19 detection, as in China under its authoritarian communist government. Think of, based on COVID-19 uses of AI, the name conjures up promising benefits for humanity, making life easier and broadening our capacity to think, to learn, and to have the potential to solve seemingly intractable problems. However, there are many uses of AI extend far beyond the few examples we have seen so far, as have the definitions for specific types of AI. Now, taking a look here, this umbrella, consider AI as it is currently used as an umbrella name under which are grouped the following means to enhance our lives, a number of which I have already touched on. AI, degrees of intelligence. Intelligence is the ability to accomplish complex tasks. Artificial intelligence is quite simply non-biological intelligence. You see there is narrow intelligence, ability to accomplish a narrow set of goals, such as playing chess or driving a car. General intelligence, ability to accomplish virtually any specific program goal, including learning given existing technologies. And then there's universal intelligence, even stronger technology, ability to acquire general intelligence given access to data and resources. This is an AI components chart. I'll just read the ones in the middle that contribute to artificial intelligence, and the ones to the left are subcategories. So you have machine learning, natural language processing, in green in the center there, expert systems, followed by vision, speech, planning, and robotics. Moore's law. Moore's law is the observation by Intel co-founder Gordon Moore that the number of transistors in the dense integrated circuit doubles every 2 years or so, between 18 to 20 months or more. Shows the growing complexity, model complexity in this graph, and also indicates the chip processing power as it increases into the future. So Moore's law is the observation that the number of transistors in a densely integrated circuit doubles about every 2 years. And in April of 2020, it marked the 55th anniversary since Intel co-founder Gordon Moore came up with this term. Recent efforts to push down integrated circuit feature size have been hitting roadblocks with limitations in economics and physics. Automation. If you were an industrial manufacturer, what benefits can you think of in replacing humans with robots? That's the next slide. But first of all, you can see in the circle to the left of the screen, that's a human being monitoring the robots. And at the bottom, of course, is a forward assembly line with many different workers putting together those Model Ts. Okay, so the advantages of robots, as you see here, are many. And with the pandemic and with people becoming ill, the manufacturers are considering these advantages of robotics more seriously. Factory of the future, well, we're pretty much there in some areas of manufacturing. Now, technology is fueling 4IR. That means the fourth industrial revolution. That's where we are. Cybersecurity up at the top, going clockwise, augmented reality, big data, autonomous robots, 3D printing, additive printing, or manufacturing, autonomous vehicles, system integration, cloud computing, and the Internet of Things, a number of which I have already referred to. This next here is brain-computer interfaces. You might recognize this gentleman here, the visionary, the genius Elon Musk. Brain-computer interfaces enables individuals to communicate or perform ordinary tasks exclusively via brainwave using EEG. He has a particular fascination with this field. And ultimately, it may be possible to meld together human and artificial intelligence. Brain-computer interfaces may redefine what it means to be human. You see this gentleman here with an artificial hand, where he is controlling that robotic hand. This just gives you some idea of the complexities involved in programming AI. Imagine what it would take to program an AI with these vast, intricate networks of knowledge sufficient for a machine to understand their complexities in ways that would be useful to humans. Isn't it an insurmountable endeavor? Not fully included in this matrix are human emotions, values, principles, ethical and moral standards. And by the way, here is under evolution and adaptation. If you go to the lower right of the screen, that's where artificial neural networks are mentioned, and genetic algorithms and so on. So there's a whole lot more than just artificially programming. All right, coming toward the end now, we have human level artificial general intelligence, AGI, ability to accomplish any cognitive task at least as well as humans, also known as human level or strong AI. And then there's superintelligence, general intelligence far beyond human level, also known as singularity. So we have gone from artificial narrow intelligence to artificial general intelligence to artificial superintelligence, and now we're advancing to machine consciousness and eventually to singularity. What is considered the ultimate measure of having created a fully intelligent device is the Turing test. So far, no one has been able to pass this test. The Turing test is a test of a machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from that of a human. We're getting closer to achieving that goal, but even the most optimistic scientists still feel we are decades away from having a machine that can exhibit all the aspects of a multifaceted human brain. In 2021, you will see Alan Turing appearing on the British £50 Bank of England note in honor of his achievements in AI. The Turing test still stands as a premier test for reaching human-level machine intelligence. This was an article in The World in 2020, The Economist Weekly News Magazine's annual supplement. And the technology editor, Tom Standage, is interviewing an expert on AI, which, as it turns out, is an AI computer that is being interviewed. Very impressive. The computer is using an unsupervised language model trained using 40 gigabytes of text on the subject taken from the internet. It's a very convincing article. But why would this computer not succeed in passing the Turing test? That is, the computer's intelligence indistinguishable from that of human intelligence. The answer is most certainly no, it would not pass the Turing test, because if I ask the machine what month it is, or who is Babe Ruth, or any other question unrelated to the topic of AI technology in the interview, it would likely fail. We don't quite know where artificial superintelligence will kick in, intelligence far greater than human intelligence. Right now, it's guesswork. I mentioned singularity. Singularity has been described as a moment when a civilization changes so much that its rules and technologies are incomprehensible to previous generations. Singularity is considered a point of no return. It now refers to a period of extremely rapid scientific and technological change when we achieve artificial superintelligence. And finally, I leave you with a quote by Ken Jennings, the greatest Jeopardy champion. And he said on Jeopardy, when he got beaten by an AI computer, he was quoted as saying, "I, for one, welcome our new computer overlords." Thank you, gentlemen, for listening. This is the end of my presentation on artificial intelligence. Good day.